Okay guys, so on your worksheet here, you've got a place for equation for the reaction. Okay, so we're gonna record this equation in that box and then we're gonna write the equation. So the equation says a solution of hydrochloric acid reacts with a solution of magnesium hydroxide. So go ahead and take a moment and write that down. You may have noticed something is missing. In this equation, they have not told us what the products are. So we're gonna have to figure that out. And that's where our discussion is starting today. We've been writing and balancing equations so far. The next thing we are required to learn is how to tell the difference between different types of reactions: double replacement, single replacement, synthesis, decomposition, combustion, which ones are acid-base, which ones are precipitate, which ones are redox. Okay, so we're starting today with double replacement reactions, and this is one of those. So we're actually going to use what we know about double replacement reactions to predict what the products of this are going to be. So we have hydrochloric acid reacts with magnesium hydroxide. Okay, so let's go through our flow chart. Hydrochloric acid is the first element metal? No. Does it end with the word acid? Yes. Does it start with hydro? Yes. So this is going to be a binary acid with an H, and then our other nonmetal is chlorine, which is Cl. H we know is 1 plus, chlorine we know is 1 minus. So when we crisscross that, we don't need to write any numbers because the numbers are all ones. Then we have our plus, and we have magnesium hydroxide. Back to our flow chart, it says, is the first element a metal? Yes, magnesium is a metal. Is there a Roman numeral? No. So we would look up the charge of the metal on our periodic table. So magnesium on our periodic table has a charge of 2 plus. Then does the second word end in IDE except for cyanide or hydroxide? Hydroxide is one of those exceptions. It is a polyatomic ion. So you look on your polyatomic ions chart. Remember, polyatomics go in parentheses. It is OH and it has a 1 minus charge. So when we crisscross this, the 2 from magnesium goes to the hydroxide. The 1 from the hydroxide doesn't go anywhere because we don't write ones. So now the question is, what is this going to make? Well, this is 2 types of reactions actually. This is a double replacement reaction, but it is also an acid-base reaction. We have an acid and we have a base. Okay? Acid-base reactions are typically double replacement reactions as well. So if you think about the term double replacement, to replace means to substitute in something comparable. So like if I go to the steakhouse and I order the ribeye, they say, oh gosh, I'm so sorry, we don't have any more ribeye. Would a T-bone work instead? That would be a replacement. They are replacing it with something comparable. Double replacement means we're doing that twice. So in this case, what's gonna happen is my compounds are gonna switch partners. We're gonna switch the magnesium with the hydrogen, okay? So if I switch the magnesium with the hydrogen is going to end up with the OH, and the magnesium is going to end up with the chlorine. Now, we need to go back and make sure these formulas are right. So I'm going to crisscross charges here. Hydrogen is 1, hydroxide is 1, so that's fine. Magnesium is 2, so we would put a 2 on the chlorine. Chlorine is 1, so we don't need to do anything with that. So here is my equation for the reaction. And then the next step would be to balance it. So take a moment and see if you can get this equation balanced. Okay, so on your worksheet, right above where we just wrote the equation, you have a place to describe step by step what is being done in this experiment, and then also a place to record the indicators of a chemical change. So things like a color change or heat and light being produced, an odor change, formation of a gas, formation of a precipitate, that kind of stuff. So what I have here in my beaker is some magnesium hydroxide. This is sold commercially as milk of magnesia. Okay, it is twofold. It is an antacid, which means it helps take care of stomach acid, but it is also a saline laxative. And the reason is that the magnesium hydroxide will react with your stomach acid to form water and magnesium chloride salt. The trouble with magnesium chloride, though, is that it is going to force your intestines to retain water, which is going to flush out your colon. So this is both an antacid and a laxative. And the reason we can use this as an antacid, bases are usually quite dangerous. They're very caustic to your tissues. They're going to eat away at your tissues. The reason we can use things like magnesium hydroxide and just straight drink them is because they're not water soluble. And if you look at my beaker here, you'll notice that it's thick. It looks like milk. It's not transparent. It's very colloidal. So this is actually a colloidal suspension, and I actually have a stir bar in there that is constantly stirring it. Okay, so keeping us nice and mixed. Now, an acid-base reaction is often kind of boring because you don't always see what's happening. So we tend to like to add what's called an indicator. And you guys have seen indicators before. My class at the Changes Lab, and we used phenyl red, which is yellow in an acid and red in a base. We also used phenolphthalein, which is pink in base and clear in acid. This one, though, is one of my favorites. It's called the universal indicator. And what universal indicator does, it's not just two colors like most of the other indicators. This is a mixture of different indicators, so that we end up with a whole rainbow of colors. Everything from purple, blue in your bases, green for neutral, yellow, orange, and then red for acids. So I'm gonna add a little bit of universal indicator to my magnesium hydroxide just so we can see the change of pH as this reaction progresses. So you'll notice that initially it turns a nice bright purple color because magnesium hydroxide is quite basic. So now I'm going to add some stomach acid. It's not real stomach acid. I sort of made this is 6 molar hydrochloric acid, so quite concentrated. And we're gonna add just a little bit and see what happens. So initially it went bright pink, but then very quickly changed from pink to orange to yellow to green and then back to a bluish color. And the reason for that is that there's still more base than there is acid. So when I initially pour the acid in, the indicator goes, ooh, acid, pink. And then as the acid gets used up, as it reacts with the base, we end up going back towards the basic colors. So let's keep adding a little more stomach acid, see what happens. So now we're getting closer to our equivalence point. So you'll notice that the pink and the yellow have stayed a little bit longer. We're sort of hanging out at an orange color. And now we're all the way to red, which means we have more acid than we have base. And one other thing that you might have noticed is that it is no longer colloidal. It is no longer thick and chunky. It is very clear because our product, magnesium chloride, is water soluble. And so you can see through this now, and you can see all the way through the solution. So go ahead and on your paper, make sure you record everything you observed, and also go through and write down what are the indicators of a chemical change that you observed. Okay, so this is the general formula for a double replacement reaction. So please write this down in your note. Double replacement reactions are where two compounds switch ions. So an AB plus CD would result in an AD plus CB. So go ahead and write that down, please. All right, so let's do a couple of these as examples. So we have magnesium chloride and silver nitrate. So magnesium is Mg, chloride is chlorine. This is 2 plus, this is 1 minus. So 2 comes with chlorine, so we have MgCl2. And then we have silver nitrate. Silver is Ag with a 1 plus charge. Nitrate is polyatomic, it's an NO3 with a 1 minus charge. So that doesn't need to be crisscrossed because it's going to cancel out. So to predict my product, I'm going to take the silver and switch it with the magnesium. So that's gonna give me magnesium nitrate. Okay, remember magnesium is 2 plus, nitrate is 1 minus, so that we would have a 2 there. And then my silver would be with the chlorine. Silver is 1 plus, chlorine is 1 minus, so no need to crisscross there. So there's my equation, and then I would simply need to balance it. To balance it, I would put a 2 in front of the silver nitrate, and then a 2 in front of the silver chloride. Ammonium phosphate. Ammonium, remember, that's that weirdo from our polyatomics chart, that NH4, and it has a 1 plus charge. Phosphate is PO4, and it has a 3 minus charge, so that 3 from the phosphate would go to the ammonium. And then we have strontium hydroxide. Strontium, Sr, has a 2 plus charge. Hydroxide is a polyatomic, OH, with a 1 minus charge. So when we crisscross that, the 2 from strontium goes to the OH. So now we need to predict what our products would be. So we're gonna switch the ammonium and the strontium. So we're gonna end up with NH4 ammonium with the hydroxide, they're both 1s, so we can leave it uncrisscrossed. And then we have strontium with the phosphate. Strontium is 2 plus, so we need a 2 next to the phosphate. And then phosphate is 3 minus, so we would need a 3 next to the strontium. Okay? So to balance this, we would need to put a 6 here. So that gives us 6 of these. So we have a 2 here. And then we would have a 3 here. Okay. Aluminum acetate. Aluminum is Al, and it has a 3 plus charge. ATE acetate, that is the polyatomic ion C2H3O2, and it has a 1 minus charge. If we crisscross that, the 3 from aluminum goes to the acetate. Then we have sodium hydroxide. Sodium is Na with a 1 plus charge. Hydroxide is OH with a 1 minus charge. We don't need to crisscross that because that cancels out. So to predict the products, we're gonna switch the aluminum and the sodium. So we would end up with sodium acetate, C2H3O2. Now there's no need to crisscross this because sodium is 1, acetate is 1. And then we have aluminum with the hydroxide. Aluminum is 3 plus, so there would be 3 hydroxides. Hydroxide is 1 minus, so we wouldn't do anything with that. So we would need to put a 3 here and a 3 here to balance that. Let's do one more. Potassium hydroxide. Potassium is K with a 1 plus charge. Hydroxide is OH with a 1 minus charge. No need to crisscross because they're equal. Then we have sulfuric acid. Sulfuric, remember there's no hydro here, so this is just going to be sulfates with an H. So we have H2SO4, sulfate with 2 hydrogens. All right, so when we crisscross this is an acid-base reaction because we have an acid and we have a hydroxide. So we're gonna switch the potassium and the hydrogen. So that's gonna give us K2SO4, crisscross your charges, plus HOH. Okay, and then to balance that, we would need a 2 on the potassium and a 2 on the HOH. Okay, so for homework for this evening, I want you to finish the rest of the worksheet. You've got 3 equations where you're going to write the equation, predict the products, and then on the back, you have a whole bunch of equations. You just need to find the ones that would be double replacement. Which ones are doing this? Circle them and then balance them. Oh, and you also have a pre-lab to look over for tomorrow, so make sure you look over the pre-lab for tomorrow's lab.